Assalamualaikum warahmatullahi wabarakatuh, and very good day to my examiner, Professor Dr. Muhammad Nazri, and also Madam Faruza. My name is Nur Dalila binti Muhammad Nur, and I'm here today to present my final year project entitled Tensile Strength of Thermoplastic Natural Rubber Reinforced with Different Woodchip Size of Leucaena Leucocephala wood. And I also like to extend my gratitude to my supervisor, Madam Junaidah binti Muhammad Sani, and also Professor Dr. Muhammad Nazri bin Wan Abdul Rahman as my co-supervisor for their continuous guidance throughout my final year project. Now I will start my presentations with an introduction. What is TPNR? Thermoplastic natural rubber is a polymer made up from natural rubber which plus thermoplastic such as polypropylene, polystyrene, or even high-density polyethylene. TPNR actually is a continuing in development for a variety of applications, including autos, seals, warehouses, and also marine engineering. The additions of natural fiber as example in this study, we want to reinforce Leucaena Leucocephala chip with TPNR itself can actually increase the performance of TPNR in the constructional and also into the building applications. So the problem statement of this study is because there exists abundance of petai belalang in the forest. So rather than we left the petai belalang without being used and thus resulting in being an excessive resources, it is better to use it for a better purpose that will bring benefits in our life. There are few factors which will influence the tensile properties of rubber compound, which is natural rubber. One of them is the woodchip size of the fibers. Different woodchip size actually will bear different tensile strength and also young modulus. Thus, it is surely important to find the tensile strength of the composites, as it is one of the ways to look for how it is suitable for light-duty purpose. The objective of this study is we want to prepare the composites of TPNR filled with Leucaena Leucocephala chips. The second one is we want to find the effect of wood chip size on the tensile strength of the TPNR Leucaena Leucocephala wood composites. Actually, what is meant by tensile strength? It is actually an indication of how strong compound is and is an important consideration specifically for application where a large force is present. Now, we will move to the composition of TPNR. To make a TPNR, we need 70% of polypropylene, 20% of natural rubber, and also 10% of latex liquid. So now we will move to how can we make preparations of the TPNR matrices. First, we need to cut the natural rubber into small pieces, and then the cut natural rubber will be put into the remixer with polypropylene and also latex liquid. And then by using the melt blending method, we will blend it for about 25 to 30 minutes with the temperature of 190 degrees Celsius with the 60 RPM, and after that we will get the final result of TPNR. So now we will move to how can we get the composite TPNR chip. First, we need to cut the TPNR into small pieces, and the compositions of the TPNR chip composite is 90% of TPNR, 10% of wood filler. And by using the melt blending method, it takes about 24 minutes to get the final result, which also the temperature of it is 190 degrees Celsius with 60 RPM. After we get the TPNR woodchip composite, we need to compress it down by using hot press machine, which is a hydraulic press at 180 degrees Celsius. The time taken for it varies with another, which is 3 minutes, 2 minutes, and also 1 minute. And the pressure also varies with each other, which is under 1800 psi, 1200 psi, and also 800 psi for the time taken consecutively. After that, we need to cool it down by using a cold press, hydraulic cold press. With the time taken of it take about 5 minutes to be done. So we will get the final composite. Now we will move to the characterization. In this study, the thermoplastic natural rubber hybrid composites reinforced with Leucaena Leucocephala wood were compounded by melt blending method. by using an interim method, which is thermoscientific high-capillary lab QC modular thermometer. The source then was screened by using Thomas Wiley Laboratory mill model for USA Thomas Scientific, as we want to make the oven-dried Leucaena solder smaller before being sieved by laboratory Thesis, as we want to get the wanted aperture, which is the size of 180 micrometer, 180 micrometer, and also 425 micrometer. This slide will show you the machine that were used by me while doing the study. Universal testing machine was used to determine the tensile strength, the modulus, and also the density of TPNR, Leucaena, Leucocephala, Woodchips. It is a machine that is suitable for measuring all types of polymers, compounds, composite materials, fiber-reinforced plastic, and also polymeric materials. We will continue to the results of the study. The tensile strength of TPNR reinforced with different woodchip size of Leucaena, Leucocephala woodchips. It was found that the tensile strength of woodchip size of 180 micrometer is higher than woodchip size of 150 and also 425 micrometer. Meanwhile, the tensile strength for woodchip size of 425 micrometer is the lowest. Since the minimum requirement for tensile strength of TPNR is 4.68, thus the three sizes of Leucaena, Leucocephala woodchips meet the minimum requirement. As a result of the tensile strength for these sizes is 8.16, 9.29, and also 6.18. Therefore, for manufacturer, the sizes of woodchips are suitable anyone they choose, as if they want to manufacture anything that is required for high tensile strength. Now, we will continue to our second result, which is for the Young's modulus of TPNR reinforced with different woodchip size of Leucaena, Leucocephala woodchips. In the graph, we will see that the highest Young modulus was for the woodchip size of 150 micron, which the average is 396. Meanwhile, the lowest youngest modulus was for the woodchip size of 425 micron. Thus, for this graph, we will able to say that if the sizes of woodchip size increase, the Young's modulus will decrease. Since the minimum requirement for the Young's modulus in between of 300 to 340, thus only the size of 425 micrometer does not meet the minimum requirement. Therefore, for applications that need high Young modulus, the size of woodchip composite that can be considered either from 150 micrometer or 180 micrometer. In a nutshell, using a different size of Leucaena, Leucocephala woodchip in thermoplastic natural rubber surely will affect the tensile strength and also Young modulus of TPNR. And the TPNR composites with Leucaena woodchip of size 180 micrometer gave better tensile strength. Meanwhile, with size of 150 micrometer is suggested for the one that required high Young modulus. But since the treatment size of 100 and also 150 micron significance to each other, which is 0.159, they both have the same characteristic. So if you want to use it, it can be even both of them, as they have same characteristic, which is the significant for each other. So actually there are two recommendations that I will suggest in this study. First, we should use a made up liquid natural rubber, not a commercialized one, as compatibilizer is really important to decide the final results of the study. The second one is we need to study the best time and temperature for the blending of composites, as time and temperature of mill composites surely plays a great importance to the final results of tensile strength and also the modulus. So that's all from me. Thank you for lending your ears. and have a good day. Assalamualaikum warahmatullahi wabarakatuh.